Hello, my name is June, and this is my project of energy system project, and my country is Hawaii. First, so Hawaii's current energy status. I'll talk about the energy mix generations, which I'll talk about especially about electricity and how the electricity is consumed and where it is consumed the most in terms of demographics and the infrastructure, where the energy is generated the most, and some goals about energy of Hawaii and some potential obstacles and related solutions that help to reach the goal. These are the five types of energy sources prior to talking. The petroleum, which is similar to coal but in a liquid state, and solar power, wind power, hydroelectrics, and other renewable sources like biomass. This is the energy mix generation. As you can see, the petroleum takes over 3/4 of the total energy source, which shows that Hawaii depends solely on the petroleum production. And something that would later be helpful to understand is that Hawaii is divided into 8 main islands, and all islands are divided with a body of water that restricts inland connections. And these 8 main islands are important because they are the major islands that generate most of the electricity in Hawaii. Some energy infrastructures that exist is Oahu's Kaya Power Plant, Kuhilani Solar Plus Storage, Kawailua Wind Farm, and Wailukuku Hydroelectrics. And from these, the petroleum and the wind power exists in Oahu. And Oahu is a really important city because it is the most populated region in Hawaii. Before talking about Oahu, we have to understand the energy consumption. Energy consumption is pretty similar to the energy production, a little lower. The sectors are divided into 3 parts: residential, commercial, and industrial, and we can see that they are kind of equally distributed. However, there is no transportation in the data because there is no electrical transportation that is happening in Hawaii. So, as you can see, this Honolulu, this part is really populated, right? And this island is called Oahu. And this is where the energy demands are the highest and where most of the 1.45 million people living in Hawaii live in. This is where the energy gets generated the most, and this information is really important later on. Some additional information talking about electricity is that, as you can see from prior, it's divided into 4 sectors, right? And you can also see from here. And these special namings represent the different companies that control the islands. And these islands don't share electricity, so there's limited transfer between the islands. And these Hawaii Islands, because they're islands, they depend on the import of petroleum because they cannot generate or produce petroleum by themselves. So this makes resources very limited around them. And Hawaii is a really good place to build solar power and wind power because it has a tropical weather where it's usually very sunny and there's something called trade wind. Trade wind happens when northern high pressure wind blows and the low pressure wind blows from the equator. They swirl, and because of convection, they flow annually and steadily over Hawaii. This is why it's a really good potential for renewable energy facilities. So, moving on to Hawaii's goal. Hawaii's government stated that they will reach 100% renewable energy by 2045. This was one of their goal, and I wanted to plan out a new energy mix overview for Hawaii. Yeah, and this is what I've got. The solar power would take up the major, and the wind power would also take up the major. And the biomass, geothermal, and hydropower would also take a portion of it. And the annual consumptions would be good if it remains the same, because we don't know how much those energy sources can produce the energy. So if it remains constant, then it means there's no variable. So I think it's safe if we just put it the same annual consumption. And this shows why Hawaii's goal is good. Reaching 100% renewable energy by 2045 holds more value than just being eco-friendly and saving the earth. Current Hawaii, because they use petroleum a lot, they get the petroleums from other countries like Argentina, Libya. And this creates tariff which increases electricity costs. And they can use less petroleum, it would lower the electricity cost and would affect the Hawaii's economy in a significant way. As I said, this is a very realistic idea because of the tropical weather, there's 2,560 sunlight hours. And I mentioned before, the trade winds provide a really good source of energy production. And this is how the power plants gonna be placed in order to meet the similar outcomes as using petroleum with only renewable energies. We have to build a lot of facilities. And current Hawaii is focused on Oahu because it has lots of population living there and inter-island connections are impossible. So in Oahu, there's lots of facilities, and in other places, there are facilities in the coasts. And building more on Oahu would create problems because there would be no space then. Because solar power should be built in higher elevations, and wind power should be built near coasts because of convection currents, where the heat capacity is lower in the ocean and the ground is higher, it creates convection, which signifies the wind power generation. It would be more better if we can build the energy facilities in the coasts and then use that energy to bring it to other islands. So to summarize, the energy facilities is too concentrated on Oahu Island even now, and the renewable energies are unstable. This means that even if we build enough facilities in Oahu, if there's a bad weather or when wind doesn't blow, it cannot generate electricity. And when emergency comes, they cannot get the energies from other islands, which makes them in a danger of a blackout. So the solution that I created was submarine transmission grid cables, which is connecting using inter-island cable network to connect the islands together. And this map is showing uh, when the Hawaii has inputted $120 million in order to create an inter-island fiber cable network which connects the cables for better internet connections. In similar ways, I think it would be possible to connect between the islands, and this would prevent the potential threats such as the blackout or electricity shutdown, and this would even create job opportunities, as this would need a lot of human labor in it. So in this way, while each islands can self-sufficient with their own energy infrastructure, however, when they are in an emergency, they can transport energies to other people in Hawaii and prevent the potential threats. Then some problems that can come out is increasing efficiency. We already know that the efficiency remains unknown compared to the petroleum. This means that we have already seen the efficiency of petroleum by the amount it produces. However, we set the efficiency same as petroleum annually. However, we don't know if the renewable energies can actually produce that much. And by building a lot of renewable energy facilities, I said that Hawaii has limited resources, which means it remains questionable whether Hawaii can build enough plants until 2045. I don't doubt that Hawaii won't be able to build that much, what should you call, renewable energy infrastructures, the power plants. However, I think it's just not possible for it until 2045. Yeah, and these are my graphs, maps, and data citations. And this is my power plant images, the four images that I used to show the infrastructures. And this is my source citation that I used as a reference for all of the information that I gathered. Thank you.